Amazon, Netflix, Spotify, and many other massive companies all use the microservices software architecture. But this architecture isn't just for billion-dollar businesses. It's been adopted by all types of companies regardless of their size because it offers a lot of flexibility. In this video, I have condensed for you my 4 years of experience building and maintaining Nest.js microservices applications into a 20-minute crash course. So I'll show you how to set up your Nest.js project, create the microservices apps, and make them communicate. But creating the services is the easy part. What will really set your application apart is how you organize your code. I'll show you exactly how to do that during this crash course, and by the end of this crash course, you'll be ready to start building a highly scalable and well-structured software system. In this crash course, we will build a backend system for a bookstore application. So in a standard Nest.js project, you will have one application with multiple modules. Typically, you would have a module for users, a module for books, and modules for other features. When a client sends a request to your app, the relevant controller handles the request. But in the microservices architecture, there are multiple applications involved in the request handling. So let me show you how that works before we start writing any code. As far as the client is concerned, nothing changes. It still sends requests to the same endpoint. But behind the scenes, the request is handled by a gateway application, which then forwards the request to other domain applications. In our case, we'll have a bookstore API gateway application that handles the requests and forwards them to the users and the books application. Even though we want multiple applications, we can still achieve this with a single Nest.js project. First, you have to create a standard project using the command nest new bookstore. Then you'll have to convert the standard Nest.js project into a monorepo project. You can do that by adding the bookstore API gateway application with the command nest generate app bookstore API gateway. Now that you have a monorepo project, you can create the other applications using the CLI, run the nest generate app user to create the user's application, and run nest generate app books to create the books application. I removed the initial bookstore application because we don't really need it. And if you do the same, just make sure to update the nest CLI JSON because you want to remove all references of the initial application. Let's start by implementing the user's service. By default, a Nest application created with the Nest factory create is a server that listens on a port and handles HTTP requests. To convert the application into a microservice, you'll first have to install the Nest.js microservices package. Then use the Nest factory create microservice method instead of the Nest factory create. That method takes an options object that specifies the transport protocol to use and the port to listen on. And in our case, we'll use the TCP protocol and we will listen to port 3001. You can remove the port from the app listen method because for microservices, the port is specified in the options object. Nest microservices can use different transport protocols like NAT, MQTT, Redis, gRPC, and TCP, like in our example. And you can even define your own communication layer with custom transporters, but that's out of scope for this crash course. Now that we have a microservice, we can add a controller to handle the requests. In an HTTP server, the controller is responsible for handling HTTP requests and returning a response. But in a microservice, the controller is responsible for handling messages and events. So in the microservices controller, the handler method in the controller are decorated with the message pattern or event pattern decorator. Message pattern is used for request-response communication. When a message is sent to the microservice, the controller listens for the message and returns a response. And on the other hand, event pattern is used for event-based communication. So when the message is sent to the microservice, the controller listens for the message and the event and performs an action. and the controller doesn't return any response back. For simplicity, we'll only be using the message pattern in this crash course. The user service is responsible for handling the business logic and interacting with a database. But again, here we're not going to use a database, so you can just return a list of mock users. The existing controller has a getHello method that is decorated with the get decorator and listens for HTTP requests on the root path. But for microservices, we won't be listening for HTTP requests, so you can remove that getHello method. Instead, you can add a findAll method that is decorated with the message pattern decorator and listens for messages with the pattern users find all. The convention I'll use for the pattern string will be the domain name followed by the operation name, and in this case the pattern will be users as the domain name and find all as the operation name. At this point we have a users application, which is a microservice that can handle messages and return responses, but there is nothing connected to the users application. So let's change that and connect the gateway to the users application. We want the gateway to receive a GET request on the user's root and forward that request to the user's application. First, you need to add a users module to the gateway application with the command nest generate module users followed by the project option bookstore API gateway. If you don't provide the option, the CLI will ask you to select the project anyway. So make sure you select the gateway. Then add a users service to the users module, again with the CLI command. You can use nest generate service users, and again you pass the project as an option. And for now, we'll just have a find users method that returns a mock response. I'll show you later how to send a message to our users application. Then add a controller to the users module with the command nest generate controller users followed by the project option bookstore API gateway. So in your controller, you can add a findAll handler method with a get decorator. So the method will handle the get request on the user's root. You can inject the user service into the controller and call the findAll method to get the list of all the users. You can quickly test the gateway by sending a get request to the user's endpoint, and you should get the mock response back. Of course, what we really want is to forward the request to the user's application to get the list coming from the user's application. And to do that, we have to create a microservices client in the gateway application that connects to the user's application. You can do that by defining a client provider in the users module using the client's module register method. So you specify the injection token and the transport protocol to use, and in this case we will be using the TCP protocol. We need to make sure that the protocol and the port matches the user's application protocol and port. So you can put whatever name you want for the injection token though. This is one way of doing it, but I'll show you a better way later on. Then you can inject the client into the user's service and use the send method to send a message to the user's application. So you have to specify the message pattern and the payload if needed, but in this case you can just pass an empty object as the payload. If you send a GET request to the user's endpoint this time, you should get the list of users coming from the user's application. Congratulations, you have successfully connected the gateway to the user's application. So these are the foundations for a microservices architecture, but if you stop there, I can guarantee that you will run into some serious issues and blockers as soon as you start adding more features and more microservices to your application. In the next sections, I'll show you how to actually organize your code and put a structure in place that will make your application scalable and maintainable. Let's recap this just to make sure that we understand what happens when a request is sent to the gateway from a top-level perspective. So the client sends an HTTP request to the user's endpoint. Then the gateway receives the request and sends a message to the user's application via TCP. And the user's application receives the message and returns a list of users to the gateway. And then the gateway returns that list to the client. So now let's have a look at the flow in more details to see what happens at each step. So the client sends an HTTP request to the gateway on the user's endpoint, and inside the gateway, the request is received by the user's controller, and the user's controller hands over the request to the user service. The user service sends a message to the user's application via the client proxy, and then we move on inside the user's application that receives the message in the controller. The controller hands over the request to the user service, and the user service returns the list of users to the controller. The controller returns the list of users to the gateway, and the gateway returns the list of users to the client. So far, we've successfully forwarded a GET request from the gateway to the microservice application. But what if we wanted to forward a POST request with a payload? So let me showcase how to do that by implementing the Books application. First of all, I have converted the Books application into a microservices, just like we did with the user's application. Then I have actually removed the boilerplate code that was generated by the CLI, because we are going to use the CLI to generate the entire Books module inside the Books application. But first, you have to rename the root module, otherwise there will be a clash with the generated module name. Then you can generate the Books module alongside the controller and the service with the command nest generate resource books with the project name Books. And you select the microservice option and choose yes when asked if you want to generate CRUD resources. If we look inside the Books controller, we can see that we have method generated for fetching all books, fetching a single book, creating a book, updating a book, and deleting a book. I'm going to change all the patterns to match the domain name followed by the operation name format. If you look at some of the generated handlers, you will see that some of them take a parameter that is decorated by the payload decorator. This is used to extract the payload from the message, and you can use that payload to pass data to the service. We also have an entity model that was generated by the CLI, and I'm just going to rename it to DTO and move it into the DTO folder. You'll see why later. So let's add an ID and a title and an author and rating properties to the DTO, and I can also add title, author, and rating properties to the create book DTO. So I have added some mock data and only implemented the find all and create methods, but you can implement the other methods in a similar way. Now that we have a Books application, we can connect the gateway to the app just like we did for the user's application. Once again, you can use the CLI to generate a Books module and with the CRUD operations inside the gateway. But this time you have to select REST API and choose yes when asked to generate CRUD resources. So just like we did in the Books microservice application, I'll rename the Books entity model to DTO and move it inside the DTO folder and add the same properties as in the Books application. Then, just like before in the users module, we'll create a client provider in the Books module that connects to the Books application. In the Books service, we can inject the client proxy and use the send method to send messages to the Books application. But this time, for the methods that need a payload, we'll pass the payload alongside the message pattern. We can test the full flow by sending requests to the Books endpoints we've just created. You could stop here and have a fully working software system, but as I said before, there are a few issues in this implementation that could lead to serious problems, and maybe you've already noticed some of them. We are going to address two major issues in the next sections. There are more than that, but we'll just focus on these two because they relate to microservices. Let's start with the first issue. So we have defined DTOs in the services applications and in the gateway application, but we have made the assumption that these DTOs in the service and in the gateway are the same. This means that whenever you make a change to the microservice application DTO, you have to remember to update the DTO in the gateway as well. So you could define the DTOs in a shared library that is used by the gateway and the microservice app, but can you guess what's the problem with that approach? Using the same DTO for the microservice application and the gateway means that every change to the DTO affects the gateway API contract and the microservice application contract, which is not always what you want. This creates a tight coupling between the microservice application and the gateway, which is something that you want to avoid in a microservices architecture. That if having common DTOs is not the solution, then what's the solution to this problem? The solution is to explicitly define the microservices application contract and make them available to all applications that want to use that microservice. So a contract is a set of rules that define how to communicate with a given microservice application, or a generic application as a matter of fact. So in our case, each microservice app will define what messages it can handle and what payload it expects and what data it returns. Those contracts will be added in a shared library that is used by the microservices applications and the gateway. Gateway DTOs will stay as they are because there is no need to share them. They are only used inside the gateway. To implement the service contracts, you can create a new library with the command nest generate library contract, and you can remove all the boilerplate code and create a folder for each microservice application. Then you can add a books folder and copy the DTOs from the books application in that folder. And after that, you can go to the books application and replace the DTOs with the models from the contracts library. But that's not all. You can create a pattern file that exports all the patterns supported by the books microservices application. Then in the controller methods, you can replace the pattern strings with the pattern from the contract library. So this way there is no chance of misspelling the pattern name. I think you can guess what's the next step. The gateway. So inside the gateway, you'll also change the book service to use the same pattern coming from the contract library. The contract DTO in the gateway and the DTO in the microservice application are exactly the same, but that's not always the case. For example, let's imagine that we only want to expose the book ID and title to the client. You can change the response model in the gateway to only include the ID and the title properties. And when you get a response back from the books application, you can map the response model to the gateway model. So the client send method returns an observable, so you can use the map operator to transform the response. And you can apply the exact same approach to the user's domain. Now you have a clear separation between the service contract and the gateway API contract. You still need to map the microservice app models to the gateway models. However, everything happens at the boundary of the service and the gateway. So this opens up possibilities to have non-breaking changes, apply transformations, and validate input data. With this approach, you can even have other gateways that use the same underlying microservices but have different DTOs. For example, you could have another API with another gateway that uses the same books microservice but exposes all the books properties. But we still have one more issue to address. When we defined our microservices client providers, we hard-coded the services port and the injection token. So this is quite a brittle approach, because imagine that you want to change the port of the book application. So you have to update the port in the books application and in the gateway. And if you forget to update the port in the gateway, you'll have a bug that is hard to track down. And the same goes for the injection token. It's easy to make a typo and not notice it, which will again cause a runtime error. To fix the injection token issue, you can define a constant that holds the injection token and use that constant in the client provider and in the user service, you can inject the client proxy using the injection token. So the port number should be handled by some configuration service that stores the connection details for the microservices application. So then in the module, you'll use the client proxy factory to create the client proxy using the connection details from the configuration service. But before you even consider using microservices, watch this next video where I explain how a large Nest.js application should be structured. It will help you figure out if microservices are the right choice for your project.